So let's talk about completing the square method. How can we use this method to solve quadratic equations? Now, there are some basic things I will need to share with you. Bring out your pen and your jotting notes and write this down. To solve quadratic equations using completing the square method, these are the basic things you need to work with. The first one, here it is. You are meant to separate the variable terms from the constant term. It's normal in news that the quadratic equations is of this form: x squared plus 2x plus 3 to be equals to 0. This is how a quadratic equation looks like. This is the standard form of a quadratic equations. Now, to solve it using completing the square method, you have to separate the variable terms from the constant term. This is a variable term. This is also a variable term. But for this plus 3, it turns out to be a constant term. It is not associated with any letters. So you have to separate it. Alright, by just saying that x squared plus 2x equals minus 3. So you have what? Passed the first step. Now, what are you going to do next? Once you separate the variable term from the constant term, here is the next thing you need to do. Number 2, you are meant to make sure that the coefficient of the variable with the highest degree of 2 is 1. What are we saying? Considering the same problem we just talked about earlier, we said x squared plus 2x then minus 3 equals 0. Now, it turns out that the highest degree of a variable we are having in this case is x squared, which is 2. Now, to solve this successfully, we have to make sure that its coefficient is 1. But it turns out that the coefficient of this x squared is already 1. So therefore, we are not to do anything. So in a case whereby it is not 1, let's say you are having something like 3x squared plus 5x minus 7 equals 0. So after separating those variables term from the constant term by having 3x squared plus 5x equals 7, you are meant to divide both sides. Divide 2 by 3 so as to keep the coefficient of x squared to be 1. So for this make 3 we cancels, and you should be left over with x squared plus 5x over 3 to be equals to 7 over 3. So here is how your expression is going to become. Alright, so whenever the coefficient of that variable that is raised to the power of 2 is not 1, so make sure you turn it to 1. Alright, good. Now the last thing you need to know is this. So number 3, you have to multiply the coefficient of the variable of degree 1 by half, square your result, and add it to both sides. So what does that mean? We said we are trying to consider an example like x squared plus 2x minus 3 equals 0. Now, to pass the first test, we said x squared plus 2x will be equal to 3. And to also pass the second test, it also says that x squared plus 2x will also be equal to 3, as the coefficient of what? Of x squared is already 1. Now the next thing you want to do is that you just want to figure out the coefficient of x here. As it is said, take it and multiply it by half. It turns out that it is plus 2. Multiplying plus 2 by half, we should have 1. So we are meant to square our result, and we should add it to both sides. Okay, now when we said both sides, we are referring to this. Okay, you are not using this, keep in mind. Good. So now 1 squared is actually equals to 1. So therefore your expression will turns out to be x squared plus 2x plus 1 equals to 3 plus 1. And then you just solve algebraically. And that's how it works. So let's try to apply this concept in some problems. So let's move. So here's an example. A squared plus 4a minus 21 equals to 0. How can we solve this problem using the completing the square method? Like we said earlier, the first thing we like to do is to separate the constant term from the variable term. So therefore, the expression will turns out to be a squared plus 4a to be indeed equals to positive 21 by the time we add 21 to both sides. Okay, now the next thing I like to do is to check, is the coefficient of a squared equals to 1? It turns out that it is a 1. So therefore, I don't have to divide any value by anything. So the next thing is just to observe the coefficient of a. then we should bring it out as plus 4 and multiply it by half and square our result. And note out what you have. 4 times half is actually 2, and 2 squared is indeed equals to 4. So therefore, I am meant to add 4 to both sides. So that is exactly what I'm going to do now. Okay. So therefore, the expression turns out to be a squared plus 4a plus 4 equals to 21 plus 4. Alright. Now, at this point, here's what you need to know. Once you are very sure that all the preceding process you did is perfect, then whatever you are going to be left over at the left hand side will turns out to be a quadratic perfect squared expressions, whereby you will be able to rewrite it in such a way that it will be the square of an expression within a bracket. So how do you want to write it that way? Just find the square root of the first term, likewise the square root of the second term, the last term, and associate them with the sign that is associated with the middle term. So therefore, the square root of a squared is actually a, then the square root of 4 is actually 2. So the next thing is that I would like to plug in this assigned sign that is for the middle term. It turns out that is plus, as I have plus 4, then I will raise to the power of 2, and therefore I have my perfect values. Okay, if you expand this back, you will get this back. So that's how it works. It's just like a way of writing an expression in such a way that it should be in a very smaller way. So this is equals to 21 plus 4, that's indeed equals to 25. At this point, I would like to get rid of this square. I know that to get rid of squares, you can always find the square root of both sides. So as to get rid of it, because square root and squares are like enemies, they do eliminate each other. So finding the square root of both sides, let me just write it on board. Okay, therefore, the expression it turns out to be a plus 2 squared, so all roots, then to be equals to the square root of 25. Okay, now this square root will cancel this squared, and I should be left over with a plus 2 equals to plus or minus 5, because the square root of 25 is actually 5, so it will either be positive 5 or a negative 5. As positive 5 squared can be 25 and negative 5 squared can be 25, so we need to consider both cases. So the next one is that I would like to solve for a by just subtracting 2 from both sides. I should be left over with a equals to plus or minus 5, then minus 2, and this is my final answer of a. If you want, you can put it in pieces. A equals plus 5 minus 2, or a equals to minus 5 minus 2. So the value of a should be either 3 or 7. It should be minus 7, and this is our final solution to this problem. Hopefully you are not getting familiar with the concept. Let's try to work out more examples. So here's another question for you. Feel free to pause the video and try to check this question out. Okay, try to apply your own ability as well, so as to know how exactly you are understanding this concept. By the way, if you haven't subscribed to my channel, please try to pause the video and go and subscribe to my channel now. Alright, let's move on. C squared minus 4c minus 2 equals to 0. What should we do? Don't forget, the first thing is that you want to separate the variable from the constant. So therefore, c squared minus 4c will be indeed equals to positive 2 by the time we add 2 to both sides. Okay, now at this point, I want to observe the coefficient of c squared. Is it 1? If it is not 1, then I need to turn it to 1. But it turns out that it is actually 1. So I need to leave it like that. It's already passed. So the next thing is that I will observe the coefficient of c. The coefficient of c turns out to be minus 4. Excuse me. Then is that I would like to multiply it by half. Just multiply by half. And squared my result. So this is indeed equals to minus 4 times half, that's minus 2. Minus 2 squared is actually equals to 4. So I would like to add it to both sides. So I should get c squared minus 4c minus 4 equals to 2. So that's actually plus 2 plus 4. So now we're having a perfect square at the left hand side. You can see the first term is a perfect square, the last term is a perfect square. Whenever you have something like this, just find the square root of the first term and the last term and associate them with the sign you have to be assigned with the middle term. So the square root of c squared is c, and the square root of 4 is 2. So the sign assigned with the middle term is minus. So this should be c minus 2 all raised to the power of 2 equals to 2 plus 4 is actually equals to 6. And I would like to get rid of the square. Just like before, let me find the square root of both sides. So I should get c minus 2 squared, then square root to be equals to square root of 6. Okay, so it means I'm going to be having an irrational root in this case. So square root cancel squared, then I should be left over with c minus 2 equals to plus or minus square root of 6. So adding to both sides, I have c to be equals to plus or minus square root of 6 plus 2. So the value of c will either be equals to plus root 6 plus 2 or minus root 6 plus 2. And this is our final answer to this problem. Hopefully you are now getting familiar with this concept. If you have any questions, feel free to comment it in the comment section below and I will reply to it as soon as possible. Let's try one more example. 5x squared minus 3x minus 2 equals to 0. Well, I changed my mind. I won't be solving this. So try to use this as a practice problem. Solve it now and send in your solution in the comment section below for review. Thanks for watching. I really appreciate it. See you guys in the next video. If you haven't subscribed, don't forget to subscribe. Thank you.